All right, starting up with example 4 now. We want to find all the zeros of f of x equals x to the fifth minus 3x cubed plus 6x squared minus 28x plus 24 and write f of x in its linear factorization. Well, in the last section we talked about the rational zeros theorem or something like that, where I can take all of the factors of 24 over all of the factors of my leading coefficient, which is 1, and those are my possible rational zeros, and so I can guess and check and try using synthetic division, or I could look at my graph, figure out where those zeros are, and use that instead. So it looks like I have a 0 at -3, at 1, and at 2. Okay, so that's 3 of my zeros. So now I'm done with the graph. I need to figure out, because I have x to the fifth, there's 2 more zeros that I haven't taken into account. So what I'm going to do is I'm going to use synthetic division with each one of these so that I'm making my polynomial smaller and smaller until I should end up with something that I can set equal to 0 and solve to find the last 2 zeros. Okay, so I'm going to start off with -3, and I'm putting 1. I don't have an x to the fourth, so that's 0. -3, 6, -28, and 24. Okay, so I have to go through synthetic division on this. I'm going to drop the 1, multiply -3 times 1, which is -3. 0 plus -3 is -3. -3 times -3 is 9. -3 plus 9 is 6. -3 times 6 is -18. 6 times -18 is -12. -3 times -12 is 36. -28 plus 36 is 8. And -3 times 8 is -24, leaving us with the remainder of 0, which proves this really is a 0 because I got 0 as my remainder. So now, if I wrote this out as a polynomial, this would be x to the fourth, because it's 1 degree less, and x to the third, and so on. Okay, I don't have to do that. I just want to make sure you understand. And then this is my number that's left over. Then I don't really need my remainder. Okay, so I'm going to use synthetic division now with 1 to try to make this an even smaller polynomial. So let's do it like this, with a 1 on the outside. And so I drop my 1. 1 times 1 is 1. -3 plus 1 is -2. 1 times -2 is -2. 6 minus 2 is 4. 1 times 4 is 4. -12 plus 4 is -8. 1 times -8 is -8. 8 minus 8 is 0. So now if I think about it, this starts with x cubed. Okay, and we could keep going, but again, I'm not going to use the remainder. I'm just going to use x cubed, x squared, x, and then this is my number. Now I'm going to do this with 2 as my 0. So drop the 1. 2 times 1 is 2. That's going to give me 0. 2 times 0 is 0. 4 plus 0 is 4. 2 times 4 is 8. -8 plus 8 is 0. So what I'm left with now is x squared plus, I don't have an x, plus a number equals 0. So what I have, I can now solve to get my x's that are left over. So I'm gonna subtract, I didn't do that right. So when you see this mess up, this is because some students that will remain nameless just came in and messed me up, but it's okay. You subtract 4 to the other side so that I can take the square root of that. And that gives me x equals plus or minus, because I took the square root, The square root of 4 is 2, and the square root of a negative number gives me an I. So these are my last two zeros. So I found all 5 of my zeros. The linear factorization is where I take each of these. Let me start off by saying f of x equals, I need to put all my zeros into factors. So x plus 3, x minus 1, x minus 2, x plus 2i, and x minus 2i. Okay, so I'm gonna stop there for now and get ready for part 3. So I know